Hello, 6th grade Neil Eagles. This is Coach Shafto from the Avengers team. Today, we are going to learn how to find the constant of proportionality from a table. Now, constant of proportionality is just a fancy word for the unit rate. But that's a vocabulary word that you'll learn in 7th grade, but it just means the same thing as unit rate in 6th grade. First, we need to do some review on what is a proportional relationship and how does it relate to ratios. We have been talking about equivalent ratios. These are ratios that have the same unit rate. A bunch of those together is called a proportional relationship. It's just a bunch of equivalent ratios put together. So in this case, we have an equivalent ratio 1 and 2. And so that ratio tells me that there is a relationship of 2 mules eating 1 bale of hay. If we take 4 divided by 2, we will end up with 2 mules eating 1 bale of hay as the unit rate. If we take 6 divided by 3, we will end up with 6 divided by 3 is 2 mules eating 1 bale of hay. Same thing, if we take 10 divided by 5, that gives me 2 mules eating 1 bale of hay. And so those are proportional because they have the same unit rate. Let's look at this one over here, cans of paint versus birdhouses that we can do. So let's take birdhouses divided by paint. That means that if we divide by paint, it's houses per can. Since it's per can and can comes last, we divide by the cans. So we're going to take 15 divided by 5. Gives me 3 houses for 1 can of paint. Or 18 divided by 6 gives me, again, 3 houses for 1 can of paint. Or 6 divided by 2 still gives me 3 houses for 1 can of paint. Let's look at what is not a proportional relationship. Over here, there's a relationship here where my unit rate is 100 pages in 1 day. So we could say that our pages per day is 100. If we divide pages per day, 300 divided by 3, we get 100 pages in 1 day, which is the same unit rate. But then, if I divide 550 divided by 5, I get 110 pages in 1 day. That is not the same unit rate. It does not have the same constant of proportionality, and so it is not proportional. In this one, we have distance and time. And so if I have not gone anywhere, then I'm still at the same place. Then if I take 10 divided by 2, because distance divided by time is speed, 10 divided by 2 gives me 5 feet per 1 minute, or 5 feet per minute. If I take 16 divided by 4, that gives me 4 feet per 1 minute, or 4 feet per minute. Those are not the same. This was 5, that was 4. And so this is not proportional. The next one says, after a shipwreck, Jenna is stranded on a desert island. She needs to build a shelter, so she makes an axe using materials from the wreckage and starts cutting down trees. What is the constant of proportionality? Write your answer as a whole number or a decimal. So we have trees per day. So I go to where the trees are, that's my y, per divided by days. 6 divided by 3 is 2 gives me 3. Let's check to make sure we're right. 12 divided by 4 will give me 3 trees in 1 day. same unit rate. 15 divided by 5 will give me 3 trees in 1 day. So that's the same unit rate. 18 divided by 6 will give me 3 trees in 1 day. This one's a little bit tricky. It says that what is the constant of proportionality? Every spring we're planting flowers. This year she plants petunias. She buys them at the garden store and brings them home. We're looking to find petunias per minute. So in 7 minutes, she plants 7 petunias. So we're taking petunias per minute. So petunias, the y-axis, divided by per minutes, the x-axis. So 7 divided by 7 equals 1. 11 divided by 11 equals 1 petunia in 1 minute. 12 divided by 12 gives me 1 petunia in 1 minute. You get the idea. This problem is a little bit more difficult. To help the environment and make some extra money, Isabella takes her empty cans to the cash not trash recycling shop. The shop pays cash based on the total weight of the cans. Isabella brings in her recycling. What is the constant of proportionality? Write it as a whole number. And we're looking at dollars per pound. So we have $1 for 4 pounds. So we take 1 divided by 4. You're like, well, that doesn't work. Yes, it does. We're in 6th grade, and so now we're using decimals. 1 divided by 4 is 0.25, which is 25 cents. Let's take $3 divided by 12, and that gives you 0.25. So you get 25 cents for 1 pound. $8 divided by 32 gives 0.25. So you get 25 cents for 1 pound. $9 divided by 36 is going to give you 25 cents for 1 pound. In the next level, you need to decide if the relationship is proportional. Donna is finding the perimeter of different sized squares. The table shows the relationship between the side of the squares and the perimeter. According to the values, is it proportional? So 12 divided by 3 is going to be y divided by x, and that's going to be 4. 48 divided by 12 is 4. 88 divided by 22 is 4. And 92 divided by 23 is 4. All of those have the same unit rate, so this is, yes, a proportional relationship. And we know that it has 4 inches in perimeter per inch in the side length. This one, again, says, Paul is a tech geek and loves his new smartphone. He is frustrated by how slowly the battery charges. After coming home from school, Paul notices that the battery is low, so he plugs in his phone to charge the battery. According to the table, is this a proportional relationship? So we see that Paul is going the y divided by x. He gets 20% in 1 hour. And then he gets 30% in 2 hours. So let's divide. 20 divided by 1 is 20. 30 divided by 2 is 15. That's not the same. So we just say no, it is not proportional. In this video, we learned how to find the constant of proportionality, otherwise known as the unit rate, from a table.